Welcome, aspiring programmers. Today, we embark on an exciting journey into the world of C++. We'll build a functional calculator, a perfect project for beginners to grasp fundamental concepts. This project will demystify core C++ concepts, making them easy to understand and apply. You'll learn about control structures like switch and if-else in a practical, hands-on way. Understanding these structures is crucial for any programming endeavor you undertake in C++. Our calculator will be a solid stepping stone to more complex and advanced applications. So, let's dive in and start coding our very first C++ calculator together. First, let's set up our environment. We begin by including the essential arithmetic library. This library allows us to handle input and output operations, like displaying text. Next, we define the main function, the entry point, where our program execution begins. Every C++ program needs a main function to tell the computer where to start. Inside main, we'll declare variables to store our numbers and the mathematical operator. We'll use double for numbers to handle decimals and char for the operator symbol. These variables are essential for holding the user's input throughout the program. Now, let's implement the logic for user input. We need to prompt the user for data. Using std::cout, we display a message asking the user to enter their calculation. Then, std::sin reads the input, the first number, the operator, and the second number. This single line efficiently captures all three pieces of information we need. Now, for the brain of our calculator, the switch statement. It allows us to handle different operations based on the operator entered by the user. We'll create a case for addition, subtraction, multiplication, and division. Each case will contain the specific logic for that mathematical operation. Don't forget the default case, which handles any invalid operator input. This ensures our program is robust and user-friendly, even with unexpected inputs. Now, let's fill in the mathematical operations for each case within our switch statement. For addition, we simply add num1 and num2 and store the result. Similarly, we'll implement subtraction, multiplication, and division. But wait, division has a critical edge case, division by 0. We must prevent this to avoid program crash. A nested if statement is our solution. If num2 is not 0, we perform the division as usual. Otherwise, in the else block, we'll display an error message to the user. This makes our calculator robust and handles potential errors gracefully. Finally, after the switch statement, we print the calculated result to the console. This provides the user with the answer to their mathematical expression. Now, let's test our program to ensure everything works as expected. We'll compile and run the code, then input various calculations. Let's try 25 multiplied by 4. The result should be 100. How about 10 divided by 2? That should give us 5. And let's test our error handling. 5 divided by 0. Perfect. Our calculator is working as intended, handling both valid and invalid inputs. You've successfully built a functional C++ calculator from scratch. Review the complete code structure, understanding each part's role. This project has introduced you to fundamental C++ syntax and logic flow. Now, I encourage you to expand on this foundation. Add advanced functions like power, square root, or even trigonometric operations. The possibilities are endless once you master these basic building blocks. Keep practicing, keep coding, and keep exploring the vast world of C++ programming. Welcome to our comprehensive guide on building a calculator using C++. We'll walk through each step from setup to a fully functional application. First, let's prepare our development environment. A clean IDE is essential. We'll create a new C++ source file, typically named main.cpp. Include essential headers like arithmetic for input and output operations. This forms the basic structure of our C++ program, ready for our code. Now, let's declare variables to store our numbers. We'll use double for precision, and a char variable to hold the arithmetic operator, like plus or minus. We'll prompt the user to enter the first number using cout. Then, we'll read that input into num1 using sin. Next, we ask the user for the desired operation, like plus, asterisk, or, and store it in our op variable, ready for processing. Finally, we'll get the second number from the user. Reading it into num2 completes our input phase for the calculation. The double data type is crucial for handling decimal values accurately in calculations, while char is perfect for storing a single character, like our arithmetic operator. These variables are the foundation for our calculator's core functionality. Now, let's implement the arithmetic operations using a switch case statement. For addition, we'll simply add num1 and num2. Subtraction follows a similar pattern, calculating the difference. Multiplication involves multiplying the two numbers together. For division, we must first consider error handling to prevent issues. A crucial step is checking for division by 0, which would crash our program. If num2 is 0, we'll display an error message and exit. Otherwise, we perform the division and store the result. Finally, a default case handles any invalid operator input. After the calculation, we display the result to the user. This provides clear feedback on the operation performed and its outcome. With our code complete, it's time to compile the program. The compilation process translates our C++ code into an executable file. A success message confirms that our calculator is ready to run. Let's review the complete code, scrolling from top to bottom. Notice the structure, variable declarations, and the switch case logic. This comprehensive view helps reinforce the concepts we've covered. Now, let's see our calculator in action with a sample calculation. It correctly calculates 25 or equals 100, demonstrating its functionality. We've successfully built a C++ calculator. Now it's your turn. Experiment with the code, add new features, and deepen your C++ knowledge. Welcome, aspiring programmers. Today, we embark on an exciting journey to build a functional calculator using the powerful C++ language. Our goal is to create a versatile tool capable of addition, subtraction, multiplication, and division. A fundamental project for any C++ enthusiast. Before we dive into coding, a proper development environment is crucial. This ensures a smooth and efficient programming experience. We'll guide you through setting up or opening your C++ compiler, whether it's GCC or an integrated development environment. A well-configured workspace is your foundation. It's where all your C++ magic will happen, so let's get it right. Every C++ program begins with a basic structure. We'll start with the essential boilerplate code, the skeleton of our calculator. The IOSTRIUM header is vital for input and output operations. It allows our program to communicate with the user. The main function is the entry point of our program. All execution begins here, defining the program's flow. Next, we declare variables to store our numbers and the chosen operator. These will hold the values for our calculations. We'll use std::cout to prompt the user for input, making our program interactive and user-friendly. Then, std::cin will read the user's input, storing it in our declared variables. This is how our calculator gets its data. Now, for the core logic, the switch statement. This powerful construct will handle different operations based on the user's input. Each case within the switch corresponds to a specific operator. For example, case plus will handle addition. Inside each case, we perform the respective arithmetic operation. For addition, it's simply num1 plus num2. Subtraction follows the same pattern. Case handles num1, num2, simple, yet effective. Multiplication is handled by case asterisk, calculating num1 asterisk num2. Our calculator is taking shape. Division, case, requires a crucial safety check, preventing division by 0. This is vital for robust programming. If num2 is 0, we display an error message. Otherwise, we proceed with result equals num1, num2. Finally, the default case catches any invalid operators, informing the user of incorrect input. This makes our program user-friendly. With the logic complete, it's time to compile our code. This translates our human-readable C++ into machine-executable instructions. Once compiled, we execute the program. Watch as our calculator comes to life, ready to perform operations. To enhance user experience, we can add a loop, like do while, allowing multiple calculations without restarting the program. This loop prompts the user if they wish to perform another calculation, making the tool much more convenient. Robust error handling is key. We can refine our code to catch invalid non-numeric input, preventing program crashes. This ensures our calculator remains stable and reliable, even when faced with unexpected user entries. And there you have it, a complete, functional C++ calculator. This project lays a strong foundation for your programming journey. We encourage you to customize and expand upon this. Add more advanced functions like square roots, powers, or even trigonometric operations. You've learned about environment setup, variables, input-output, conditional logic, and error handling. A comprehensive C++ introduction. Keep coding, keep exploring, and keep building. Your C++ adventure has just begun. If you found this tutorial helpful, please like this video and subscribe for more C++ programming guides.